Hello everyone, today is February 8th, 2022. Today's problem is two sums. Two input array is sorted. Given a one-indexed array of integers numbers that is already sorted in non-decreasing order. Find two numbers such that they add up to the specific target number. Let these two numbers are numbers index 1 and numbers index 2, where index 1 greater equal than 1 and index 2 greater than index 1, and also less equal numbers less, the array's length. Return indices of the two numbers, index 1, index 2, added by 1 as an integer array index 1, index 2 of the last two. The tests are generated such that there is exactly one solution. You might not using the same element twice. Your solution must use only constant extra space. Okay. That's the example. That makes sense. That's another example that also makes sense. And this one. Okay. So constraints. The numbers array length from 2 to 30,000. And the numbers range from 1 minus 1,000 to plus 1,000. Numbers solid in non-decreasing order. A target is same range. The test generates such that there is exactly only one solution. Okay. Okay. So since this problem, this exercise practice is under the binary search, I'm searching the binary search. Basically, that's sorted array. So let me think. Basically, I'm thinking for the array, I calculate from top to the bottom. With searching from the first element to and let target minus the temp element and searching the result in the left side. And that's also a little trick to check to check the result. The target minus the element result is greater or less than the element we are searching for. If greater, we could searching backward, forward we're searching the less than we're searching the forward. Okay, that's the trick. I think that's pretty much. Let me copy this one and back to my favorite editor. Okay. 2 sum 2 input array is sorted.c. Okay, like I said, I need a very basic bool binary search. Okay, that's then the numbers and the length target. No, we don't need length, we just need a start and the end and the target. That's much easier for me to implement. So, and the same things, made equals start equals minus and minus start divide by 2 while start okay lies equal and we do search if numbers made greater than target, so we searching backward. Else if numbers made is less than target, we searching backward. Else we just return true. And if we go out of while loop, that means we failed to find it, we return false. Okay, and I need an index. I'm thinking for the search strategy. So I'm thinking, let me finish this first, then I will do the further second consideration. So first one, I need the index for that one. I also need a return. Okay. Yeah. And let me initialize the return size equals 2, since that's always equals to 4. I equals 0 to I plus I minus I less than number size I plus plus O to the while loop, no, the for loop. So if target minus numbers I greater than numbers I, then we search if binary search numbers I at the start, number size minus 1, and target if that is true, we just need return equals int catalog size of int, so return oh okay, so in things that need an index, so we need return the target, return the index of element to equal to the target. Okay. Successful failure failed failure minus one. Index equals 0. Okay. We will check minus 1 return 1 equals index plus 1. Then break else. Else. I'm thinking if I need to tell equals 1, or we could else do the else in the either direction. We could simply do either direction. Okay, let me do this. 39 to 43. Okay, so index, that means number target minus my number I less equal than numbers I. So we need a searching forward. So we need I'm thinking if there is a good to using the 0 as the forward. So once we hit that we we need a search I+1. Okay, so once we hit that one, that means we already searched. Actually, we already searched, so we already covered the else case. In former search, so we just skip this branch. Okay, so that's the one. And when I create the for loop, we just return the return. Okay, so let me think. Yeah, we just need a one-way searching all the way up. Yeah, here we go. So it looks like the time complexity is n times log n. Yeah, pretty much. Okay. Finish coding. Let me try to run it over the Leetcode. Run the first example. Okay, that's failed to search. Okay, search -1. So let me check. Target is 9. 9 minus 2 is 7. So we just searching the 1, 2, 3. That's 1, 2, 3, right? Start. One, two, three. Okay, so the main start and made target. I don't see the problem. Okay, that's the D, so let's do it again. Okay, 1, 3, 4. How that equals 4? One, 3, 0. Okay, that's still a bit of problem. But anyway, that's 1, 3, 2, 9. That looks right. So we're searching 2. 2, 2, 2 in 1, 2 to 11. So 11 is greater than. Okay, target is wrong. So we don't search in target. We search in target minus numbers I. Okay, again. 7. Okay, so that's right. 11 is greater than 7 if made is less than and equals made minus 1. So made minus 1, how that happen? Hold on. If made greater than target, we need start equals else and equals made minus 1. That's right. Okay, so 3, 3, 3 target. That's not right. That's not right. Eleven. How that happen to 0, 1, 2? That's right, 11. Yeah, that's 11. 11 is 11 is greater than target. Oh, it's wrong side. Let me think. If the made greater than target. Okay. We need searching forward. Okay, that's wrong side. Sorry about that mistake. Now here we go. I got right answer. Let me submit again. Wrong answer. So expect 1, 2. Zero. When do 0, zero is target minus 0, that's 0. 0 is greater. Okay, I need add equal right here. Let me check. Okay, that looks right. Okay, that time exceed. Okay, looks that's right. Submit again. Okay, that's accepted. Let me check performance. Okay, that's only 29%. Let me run that again and see the check performance consistency. Okay, 50. Okay, summarize what I changed from top to bottom. Let me think. Oh, I finished the logic. So for the made greater than the target, we need searching backward. For the made element less than target, we're searching backward. And at the very beginning, I designed the binary search function return a boolean result, but that's not enough. We need to return the index of the element to equal the target. So I changed that one, and I defined failure return -1. Over there, that's another fix for that one. I made a mistake star plus. I typoed minus. That caused the problem. I fixed that. Another thing is uh, I need to include things on the very beginning I analyzed thought we could handle the equal condition in the else section, but after I skipped the else function, which is covered on the first one, we also need to include the equal condition in the first if loop, but I didn't, so that caused some test case failure. Yeah, another thing fixed is the target is not target. It will be the target minus the element. So that's the issue. So finally, I got 50%, beat 50%. This is another one. This 50% performance. I think that for me that's good enough for the binary search strategy. As I know, best performance maybe is the counting. That's searching counting from backward and forward, from top and bottom. That's the add the check the sum to element add up, and check the target, check the result, and compare the target. If that's greater than target, we're just moving the end left side one, and if that sum is less than target, we're just moving the start to the right side to the Boolean forest. I think that's the best algorithm for the performance, but this is under the binary search. I think that's okay. Yeah, that's all for today.